Today we will discuss about one important application of magnetic circuit. So it is the application of magnetic circuit. We already know what is magnetic circuit. I am just recalling this. We know that magnetic flux lines forms a closed loop. Okay. Now, if all the magnetic flux associated with a particular distribution of current is confined to a rather well-defined path, then we speak of a magnetic circuit in close analogy with electric circuit. Okay. Now the problem, just again recalling the fact that in case of electrical circuit, with the electrical resistance is equivalent to reluctance, and it is given by L by mu A. L by mu A is the reluctance. The entire quantity is called reluctance. This quantity is playing the role of resistance in magnetic circuit, where L is the length of the magnetic material we have chosen for forming the circuit. Mu is the magnetic permeability of the material, and A is the cross section of the material. And another thing, EMF in electrical circuit is equivalent to MMF in magnetic circuit, and it is given by capital Ni. N is the number of turn, I is the current. So these are the information we have already taken. Now come to the discuss our today's application. Suppose the application problem is like this. Suppose there is a circular shape of magnetic material, and there is a small air gap. And this is the wire, electrical wire. This is electrical wire. Current moving in and current, sorry, this is with coming out. Delta L is the air gap. We will see what is the benefit of keeping some air gap here, and we will make the necessary calculation of the reluctance of the system, magnetic field intensity produced in the system, and the flux produced in the system. These are our target. Suppose the average radius of the circular path is small. Here we have taken delta L is very small than 2 pi. Sorry, delta L is very small, than smaller than A. So this path is very small. This path is very small. Total reluctance of the circuit will be reluctance due to reluctance of the solid path plus reluctance in the air gap, because these two reluctance are in series. So effective R in this problem becomes, according to this definition, L by mu A. What is the effective length here? Effective length is 2 pi a minus delta L by mu a. Mu is the magnetic permeability of the material chosen. 2 pi a minus delta L plus delta L by mu 0 a. Delta L by mu 0 a. Okay, because here the magnetic permeability of this air gap is mu 0. So delta L by mu 0 a is the effective cross section area of the of the material chosen. So net flux phi equal to mmf by Rm or R effective, from where it has written in case of electric circuit I is equivalent to, in case of magnetic circuit it is equivalent to phi. So I is equal to EMF by resistance, here it will be mmf by effective resistance. Okay, so this will come out as Ni, mmf is Ni, we have given this written here, by 2 pi a minus delta L by mu a plus delta L by mu 0 a. Clear? 2 pi a minus delta L by mu a plus delta L by mu 0 a, where I is the current passing through the windings, where N is the number of turns. N is the number of turns. I is the amount of current passing. N is the number of turns. Now as you see, as mu 0 is very less than mu 0 is very less than mu, the presence of air gap increase the reluctance. This mu 0 is very less than mu, so the presence of air gap, the quantity will rise and this will reduce, this will increase the value of phi. This will increase the value of phi. So our primary target is to increasing the value of phi. From this relation we have seen that due to presence of this term and mu 0 being very less than mu, value of phi will increase. So this is our benefit, this is the achievement. Now in this case larger number of ampere turns will be required to produce the same flux as without air gap. If there was no air gap, you see, if there is no air gap, then this quantity will remain absent, and in that case, in order to increasing the phi, this term is absent. In order to increase phi, you have to increase Ni. Therefore, you have required more number of turns. That is a problem. You have required more and more number of turns, and this problem has been eliminated when we insert a small air gap in this path. Now the value of B can be written as phi by A. And what is phi by A? It will be Ni by 2 pi A minus delta L by mu plus delta L by mu 0. This is, you can write this as expression number 2. Clear? Just A has been cancelled out. Okay, so this is the expression for B, and this expression for B will be same both in material of the ring and without air gap. You will get this B both in the material of the ring and air gap. This is because this portion is very negligible. The value of H, this value of H within the material will be given by B by mu. This will be within the material, and within air core, within air gap it will be within air gap it will be H0 equal to B by mu 0. So value of H will be changed because mu has been changed, but value of B is remaining same in within the material and within the air gap. So this what we have taken the advantage is that we can able to increase more flux. We are able to increase more flux. Flux is equivalent to current. Flux is equivalent to current in electrical circuit. So we are trying to increase current in electrical circuit, and we will say that we are trying to increase magnetic flux in the magnetic circuit, and this can be increased very easily if we place create a air gap within the material. So this is our advantage, and this is the total discussion based on the application of magnetic circuit.